This video is all about production planning systems, and as the name suggests, production planning systems is all about ensuring that the product is manufactured in the most efficient way possible. There's several factors to manufacture that the designer has to consider, and we'll take these one at a time. The first one being automation. Now, production lines used to include, and in some cases still do, lots of people, hands-on, getting involved in the manufacture of the product. However, with the introduction of more machines, robots and automation started to take over. So their jobs were replaced with robots, which could do potentially more production runs, costing less money. The social impact, however, is a rising unemployment. However, it does mean cheaper goods. These would be skilled workers, semi-skilled workers who would find themselves out of jobs. The next part of production planning is CAD/CAM. Comes in many different ways. 3D printing, where a part is being built from the ground up in layers. Excellent for testing things like clips and so on to see if they fit properly before having the injection mold hundreds of thousands of them. The other types that you need to know about are CNC routers, CNC lasers, and CNC lathes. Usually faster than by hand and possibly more accurate than by hand. And again, we've got that automation. The part can be made, 24/7. Standardization is to do with common standards for parts and perhaps products across the world, i.e. standardized. In standardization, we may have parts which have to meet specific technical requirements, such as engines or bolts and so on and so forth. Standardization means that no matter where you are in the world, these parts will be made to certain standards. Standard components, on the other hand, are the parts which are made by a specialist. So for example, nuts and bolts, or zips on a jacket. Whenever a designer is designing, they always bear in mind standard components, because this is much less expensive than designing and manufacturing bespoke parts from scratch. So if they were to design a chair, for example, they would design with certain types of bolts in mind. The issue with standard components is a quality assurance one. They have to make sure that the quality of the component coming in is good enough for their product. Just-in-time manufacture concerns the purchase of standard components and the manufacture of parts to arrive just in time, i.e. they don't want lots of components lying around just waiting to be used. It's much more efficient to have these components arrive just in time, ready for manufacture. The alternative to this is to actually store these components in vast warehouses, which costs money. There's security to think about. Sometimes the warehouses themselves need to be climate controlled, so it can be really expensive. The problem is, if you have a problem with your just-in-time manufacture, say a machine breaks down, then that can actually lead to massive problems as there are no spares. This may lead to the entire production line shutting down. Flexible manufacturing systems, as the name suggests, are systems which are not rigid. They're able to react and adapt. So for example, if the manufacturing plant needed to start producing a different type of product, it should be able to do this without too much upheaval. It's deemed to be a greater efficiency as the plant is able to make a wider range of parts and less time being invested in switching over machines and so on. The next part within production planning systems is subcontracting. Subcontracting is fairly straightforward. what happens is you have a main contract given out to a company, and then this is divided into subcontracts. So all the jobs are broken down. So if we take an example of a football stadium, the main contract may be awarded to a construction company such as Bar Construction. They will then take that stadium plan and break it up into the separate parts, so i.e. subcontracting it. They create separate contracts, which is kind of apart from the main contract. So they might have ones for the concrete, the electrics, or any steel work. When we consider this from a design point of view, the subcontracting might be that a design house is given the main contract, and it might be a small design firm, so then therefore they subcontract it out to specialists. So it might be specialist material technologists, specialist lawyers, or any part of the design team which they feel they have a weakness in. In-house design teams, as they're known, have all of these design team members within the team, so they don't need to subcontract. Smaller design houses would have to subcontract. For example, they may not have a team of lawyers in their 52 weeks of the year. So there's benefits and weaknesses to in-house versus outsourced design teams. In-house design teams, they're all pulling in the same direction, they're all looking for a successful product, and their livelihoods potentially depend on the next product being successful. Outsourced design team members, for example, lawyers, may be less inclined to care about the success of a product, maybe more inclined to just be worried about, picking up the next paycheck. Moving on to time management in terms of production planning systems, there's two ones that you need to be familiar with. Gantt charts, which write the tasks down the left-hand side and the time available across the top. And they split it up to create a really graphical version of all the jobs that they're required to do. So here we can see the task getting blocked in, and then the second task maybe taking a little longer. The third task, is maybe a short task. And very quickly, you can see the tasks as they are, appear in the timeline. This can then point out any bottlenecks or snags in the manufacture of the part. Flowcharts similarly show all the jobs that need to be done in order. Sometimes you have jobs running concurrently, and therefore we get this branching. Again, a graphical way of representing the time and the jobs that we have to do. And the final part of production planning system is quality assurance. Simply put, quality assurance is all about making sure that the product that leaves your warehouse is high quality. So quality assurance is broken down into several parts. The first one is the materials. So, are the materials that are coming into the warehouse of suitable quality? If the raw materials coming in the door are not suitable quality, then that will have a detrimental impact on the products that you are creating. So you need to test whether or not the materials that are coming in are good enough quality for your products. Similarly, components, for example, standard components, are the standard components themselves of a suitable enough quality. So for example, your nut and bolt might be made out of steel, but were you expecting it to be made out of a higher tensile steel or a higher carbon content steel? Is this steel that they've given you much more like cheese? It's kind of just, not up to scratch. We then move on to training and monitoring of staff. That's all to do with ensuring that your staff are skilled. The monitoring means that are they, cutting corners, or you maybe have to have some degree of keeping an eye on them to make sure that they are performing their job well, to ensure that the product is quality as it leaves. And then the final part of this is sampling. So as we see here, the production line, you've actually got a human there who's able to look at products and check to make sure that the product is being manufactured correctly. In some instances, this is taken care of from an automation point of view. Okay, so that's a brief run through of the production planning systems. Remember, production planning, in a nutshell, is all to do with generating effective, economical products and manufacturing those. Each of these areas are key considerations in the manufacture of products. So take some time to perhaps re-watch this video and ensure that you've got the key areas down. Thanks for watching. See you next time.